Hello students, we are going to review carboxylic acid and derivatives class exercise 2. Okay, so for question 1, it's a previous A-level question. We have chlorogenic acid treated separately with the following reagents. You are asked to draw the structure formula of all the organic products formed. So we'll highlight the keywords. The keyword is structure formulas, meaning you need to draw it out, and then organic products only. That does not include CO2, so please remember that. Then, as per all questions related to reagents and conditions and drawing of the products, it will be very helpful to go through and maybe to revise the function group present in chlorogenic acids. So over here we have carboxylic acids, okay. Then we have two phenolic OH, so these two are phenolic OHs, okay. So I'm just going to highlight them. These are phenolic OH. Okay, and then we have an ester linkage, right? And then over here we have an alkene, okay, CC double bond, and finally we have two secondary alcohol, okay, and of course a tertiary alcohol. Okay, I did not name the benzene ring because the benzene ring is part of the phenolic OH, because generally we call the functional group phenol as a whole. Yeah, but it will always be good for you to know how to call the hydroxyl group. Okay, so just be direct about it. Phenolic OH, secondary alcohol, tertiary alcohols. Okay, so question is the reagents given to you over here, sodium carbonates. So based on what we understood, sodium carbonate will only react with carboxylic acid. Okay, so I'm just going to draw the products rapidly. Okay, so I'm just going to draw in blue. Okay, some students find it difficult to draw this kind of structure fast, but if you take a look at this quaternary carbon over here, right? Okay, this quaternary carbon, you can actually draw it quite easily by drawing across like this. Okay, so you can, based on it, you can actually draw your unknown or your answers quite fast. Okay, I'm not very good at using the stylus. That explains why there are several issues involved. Okay, so it's actually okay. Right, okay, so it looks good now. So the phenolic OH will remain because they are not acidic enough to be deprotonated. Secondary alcohol remains as well. Tertiary alcohol remains. Carboxylic acid will become carboxylates. And then we need to draw out the counter cation. So remember that CO2 is not considered as organic. Okay, so that's the number one mistake some students make in the enthusiastic, they being very enthusiastic in wanting to respond to the question, draw out CO2, but CO2 is not needed, so you don't have to draw out CO2. Okay, second mistakes which will be costly would be forgot to indicate the counter cation. Yeah, so this will be a very costly mistake. Remember to include the counter cation because the question asked is products. Products, always remember something that you can isolate. So you can't isolate an anion, right? You have to isolate a salt. Okay, so in this case, the carboxylate salt, the sodium carboxylate salt. All right, sodium hydroxide heat. Okay, so the keyword here is heat. If you simply include sodium hydroxide, it will simply the system will simply undergo acid-base neutralization reaction. So for acid-base neutralization, we are looking at the two phenolic OH and the carboxylic acid. Yep. If you heat it, then you are expecting some form of hydrolysis. So hydrolysis of what? Hydrolysis of the ester. Okay. So because of that, I'm just going to draw the whole thing out quickly again. So the tertiary OH remains, secondary OH remains. Okay, so this will be the carboxylates. Okay, O minus and A plus. Okay, and then this ester linkage, it will become the alcohol. Okay, and then of course for the other end, it will become the carboxylate salts. Okay, and then I'm just going to draw it out the alkene, and then after that, the phenolic OH will be deprotonated, so O minus Na plus, and then O minus Na plus. So again, you do not need to include water. Okay, it's not necessary. Okay, then finally we have PCl5. So PCl5 is a chlorinating reagent. So what does a chlorinating reagent do? Usually to convert hydroxyl group to Cl. Okay, so we count how many hydroxyl group we have. We have 1, 2, 3. Carboxylic acid, you have 1, so 4. Yep, but phenolic OH will not be converted to Cl. Yeah, so it's a common misconception that phenolic OH do not react with its PCl5. The truth is it does react. Okay, it does react, but in the course of the reaction, right, the intermediate will not be replaced by chloride. Yeah, so you will get something like an O. You're going to get a phosphate kind of intermediate, but eventually when you isolate the product, it might not be stable enough to isolate it. Yeah, so eventually you might even get back the phenol. Okay, so in that case, we ignore what happens to the phenolic OH in its entirety. So we just keep it as phenolic OH, and then the rest we just replace them with Cl. Okay, so I'm just going to draw it out again very quickly. Okay, so this becomes the Cl, this becomes the Cl, this becomes the Cl, then the acyl chloride is formed, so Cl over here, and then I'm going to keep the ester, okay, and then the phenolic OH will remain as phenolic OH. Okay, yep, that's about it. Okay, so I think number one rule here is know your reactions, be able to link the reactions. So I think this is a very important part of revising for organic chemistry. Okay, yeah, next I'm going to move on to question 2. For question 2, we have compound E decolorizes bromine water. What does it tell you? Probably it contains an alkene. Okay, question say compound E. So compound E, you are given a molecular formula, C2H2O. So I don't think there will be phenol, because for phenol minimally you need 6 carbons. Okay, so over here I think you can safely say that E is likely to contain C-double-C. Okay, a solution of G has a pH of about 3. Okay, so when H2O is introduced to E, you get G. So you realize that H2O sort of adds across to the compound. Okay, so likely to add across either a CC or a CO double bond. Okay, something along those lines. How do I know that E contains CO? Well, I mean, okay, so first of all, right, when you try to draw E out, it will be helpful if you draw it in the displayed formula. Okay, so you know that there's a C double bond C. Okay, you know that there are 2 H's, right? So if you try to put a H anywhere, you notice that you can only put it at the end of the carbon. Okay, and then you are forced to put a double bond O here. Why is that the case? Because if you try to put a H here and a H here, right, you will end up with a very weird oxygen. Okay, you put it right in the middle, and then it's bonded like this. So this is going to be extremely unstable, because again, you are forcing a bond, this bond over here, right, this air bond angle, supposed to be 120 degrees, you're forcing it to take on an angle of 60 degrees. So this is highly undesirable. Yeah, so not likely for you to draw something like epoxy kind of structure, or 3-membered ring with a CC double bond in the middle. This kind of structure exists, okay, yeah, but not in this format. Yeah, and if you read on the information, right, you notice that upon adding HCl, right, you form something which can be easily hydrolyzed in the presence of water to give G. Okay, so with that, maybe we try to draw G. You notice that G, right, if you do a quick calculation, it has a degree of unsaturation of 1. So that means that maybe CC double bond, maybe CO double bond, but yeah, but if you search really hard, CC double bond is likely not to be present. Okay, I mean, if you try to draw your compound out. Okay, so let's try to draw this out. So we'll draw this out. Okay, let's try to draw one with a CC CO double bond. Okay, there we have a carboxylic acid, OH. Okay, so that means that the H2O adds across the CC double bond instead of the CO double bond. Because if you try to add across the CO double bond, you're gonna end up with something like this: OH here, and then wait, let me just try CO double bond, and then another OH. Okay, something like this. And for those of us who know a little bit more about organic chemistry, where an sp2 hybridized carbon should not be bonded to more than 1 OH, then you notice that this portion is not stable. Okay, so immediately, even if you draw something like that, it will undergo what we call a tautomerization reaction, okay, to give us a CO double bond. So that means that over here, right, the CC bond will sort of shift to this position, and then the H will be shifted to, this H will be sort of shifted to here, and then you get the carboxylic acid. So whatever the case is, you will still end up with a carboxylic acid. And how do you know it's carboxylic acid? The clue given here is it has a pH of 3. Yeah, so if you get a dihydroxyl, then it's not likely to take on a pH of 3. Yeah, so because of that, I would conclude that my G is likely to be ethanoic acid. My E is likely to be a C double bond C with double bond O. This is known as a ketene, but I will not go into explaining this further because ketene is not likely to be tested directly in a H2 curriculum. It's being tested here because you are given some clues to move from E to G or E to F to G. Okay, so that means that F is therefore likely to be an acyl chloride because the reaction you are familiar with HCl, right, is that it adds across the double bond. Okay, so we have HCl here. So okay, let me just draw the HCl. Okay, Cl, and then it's likely to add across the double bond. Okay, you remove this. Okay, so therefore my F is likely to take on the structure of an acyl chloride. Okay, that will look like this. Okay, then now it makes perfect sense that when this acyl chloride is added to H2O, it gets hydrolyzed almost immediately to give me the ethanoic acid. Okay, yeah, so I'm done with question 2. Finally, we're going to move on to question 3. For question 3, we have compound A. Again, C6H10O2. A quick calculation of the degree of unsaturation will reveal 2. Yeah, so 2n plus 2 minus 10 divided by 2, so 2 degree of unsaturation. Decolorizes bromine water. So again, decolorizes bromine water. We can sort of conclude that a CC must be present. Some form of electrophilic addition is taking place. Why did we say that there isn't phenol present? Well, degree of unsaturation throw some hints, because if there's a phenol, the degree of unsaturation will at least be 4, so it will not be 2. Okay, so in this case, I would say likely to contain CC double bond, electrophilic addition occurs, does not give effervescence with aqueous sodium carbonate, which means absence of carboxylic acid functional group. So no carboxylic acids. Okay, when heated with sulfuric acid, A forms B, okay, and C. Okay, so that means that A, right, with a formula of C6H10O2, when you heat it with sulfuric acid, some students ask, what kind of reaction is this? Well, usually when you heat a solution with either mineral acids or alkaline, you're expecting some form of hydrolysis. Okay, so I get B, which is C3H4O2, plus C, which is C3H8O. Okay, so this is some form of hydrolysis. Some students again might also ask, if we backtrack, right, is there any other conclusion we can give for this, since it does not react with sodium carbonate? So how do you account for the 2O, etc.? So because we conclude there's no carboxylic acid and there's likely to be a CC double bond, what do you think will be the 2 oxygen? You can't exactly conclude at this stage, but if you wish to, you can say that perhaps an ester might be present, which will account for the remaining degree of unsaturation, because degree of unsaturation of 2, right, indicates that one of it is due to CC double bond, or maybe 2 of it. I mean, I don't know, but it could be 1, it could be 2. Yeah, but since they tell you that there's no carboxylic acid, so because a carboxylic acid will give you another degree of unsaturation due to the C double bond O, then now they tell you that there's no carboxylic acid, then it's likely to contain maybe an ester. I mean, you're not sure. Yeah, but you can sort of be a little bit clearer after you read this clue. When you heat it with sulfuric acid, you get these 2 compounds. If it's an ester, it undergoes hydrolysis. That will make perfect sense. How do you know is hydrolysis? Again, we go through the same idea. If you add the molecular formula of these 2 up, okay, you're going to get C6 H12O3. Okay, if you subtract C6 H10O2, right, you get H2O. So indeed, the reaction of A to B and C is an acidic hydrolysis. Yeah, so that clue does tell you that A is likely to contain an ester functional group. Okay, but of course we can read on. Okay, so of course if A contains ester functional group, B must contain a carboxylic acid. Okay, you might ask why. Simplest reason, contains 2 oxygen. So therefore B contains carboxylic acids, C contains alcohol, and in particular C is a saturated alcohol. Again, based on degree of unsaturation, 2n+2. Okay, you can further conclude that B is a carboxylic acid by looking at this particular reaction when they say that B reacts with sodium carbonate to give effervescence. So you can therefore conclude that B is a confirmation. B indeed contains a carboxylic acid functional group. Okay, when B is treated with KMnO4, you get CO2. Yeah, so again, why is that the case? You might be wondering, 3 carbon, how come I get effervescence of CO2 again? Well, if you take a look at this whole process, right, C does not contain any degree of unsaturation. And originally, my ester A contains 1 CC double bond. So the CC double bond is either at the carboxylic acid end or at the alcohol end. And because C, being an alcohol, does not contain degree of unsaturation, any degree of unsaturation, the CC double bond must be present in carboxylic acid B. And if the CC double bond is present in carboxylic acid B, it must be a terminal alkene. Why? Okay, so there are 2 reasons why. Number 1 is based on this clue. Effervescence of CO2 is observed. Another reason is if you try to draw B, you can't draw anything except a terminal alkene. Okay, basically a carboxylic acid must be right at the end. So I draw a carboxylic acid. And next to a carboxylic acid must be a carbon. Okay, and if I draw out another CC double bond, then you notice that this is indeed a terminal alkene. So if I try to draw this out, this is what I'll get. So altogether 4 hydrogen, 3 carbons, 2 oxygen. Okay, so this fits the molecular formula for B. Okay, yeah, so therefore I can conclude that my carboxylic acid B is the structure I have drawn in orange over here. Okay, maybe I can indicate this is B. Okay, then C give yellow PPT when warm with aqueous alkaline iodine, so therefore C must contain a methyl alcohol group. Okay, so therefore it is likely to look something like this. It's a methyl alcohol. Okay, right, and when treated with KMnO4, it gives D. So again, D contains only 1 oxygen, so this further confirms that it's a secondary alcohol because secondary alcohol upon oxidation gives you a ketone. When treated with 2,4-DNPH, it gives orange PPT. Yes, indeed it's a ketone, and then suggests the structures of A to D, right? So if I conclude that my C is like this, my B is like this, and my donkey is propanone. So what do you think is A? I just need to combine B and C. So I'm going to draw it out quickly. Okay, like this. Okay, yep. So upon hydrolysis, this portion gives C, this portion gives B. Okay, yeah, so that's the end of the review to class exercise 2. I hope you find everything useful. Especially in the thought process, in the deduction. But of course, as I mentioned very often during tutorials, you need to write out your conclusion properly. So you're supposed to explain the reaction involved. So the best way to explain is to tabulate your answers. Okay, tabulate means I must have the evidence or we call information, and then based on the information, how can we deduce what does the information tells us about the unknown. And along the way, I have already indicated to you what are the things to mention because, for example, I mentioned that okay, if it decolorizes bromine water, so likely to contain CC double bond, electrophilic addition occurs, you know, that kind of reasoning which I verbalize in the review, right? It has to be put in the table. Okay, so that's the end of the review. Thank you very much.